Welcome to part 2 in this exciting series of Should I Differentiate or Integrate? We have some questions we're going to be looking at today, and we're not actually going to be working at any of these questions. What we're going to be doing is deciding if each part of the question calls for a derivative or an integral. Starting here with part A, it says, is the speed of the particle increasing or decreasing at time t equals 5.5? Well, in order to know if something is increasing, if the speed is increasing or decreasing, you have to compare the signs of the velocity and the acceleration. If the signs are the same, the speed is increasing, and if the signs are opposite of each other, the speed is decreasing. So this one doesn't really involve taking a derivative or an integral. I'm going to skip that part. Where it asked me to find the average velocity for the time period from 0 to 6, I know I would have to add up my velocity values from 0 to 6 and then divide by 6 minus 0. So I'm going to call this an integral. Total distance traveled, well, I would have to integrate the absolute value of the velocity. And so I'm going to call part C also an integral part. And here in part D, particle changes direction exactly once. Find the position of the particle at that time. I know the particle changes position when the velocity is equal to 0, and then to find the position, I'll have to integrate the velocity from the initial time of 0, and I need to remember to include my initial condition there. And so then I'll go from 0 to whatever time value I found over here. So this is mainly an integration problem. Lots of integration on this one, not much differentiation. Let's go on to question number 2. Question number 2, we're going to approximate a rate. Well, I know a rate is like a slope, and so that one is more like a derivative problem. On part B, I can see this is an integral, and specifically it's an average value integral, so I'll call that integration. Now this one is interesting. We have both the integral and the derivative together. So I'm going to list this as integral and derivative in the same problem. Part D, I'm given a rate and trying to figure out how much cooler the biscuits are than the tea. So I have the temperature of the tea given. I would have to find the temperature of these biscuits, and since they gave me B prime, I'd have to integrate in order to get the temperature of the biscuits. So this is an integration problem. Let's keep going. Question number 3, write an equation for the line tangent to the graph. In order to get the slope of a tangent line, I have to take a derivative. So there's a derivative in that part. To find the area, I would integrate. And in here it says, write an integral expression. So that one involves integration as well. Let's keep going. Now we're up to question number 4. Let's see, in question number 4 in part A, they ask us to find G. Well, G is defined as an integral, so I'm going to say that does involve an integral. And then I have to take a derivative. So notice I'll be taking the derivative of an integral. So this is one that really involves both. In part B, it says determine the x-coordinate at which G has an absolute maximum. Well, to find an absolute maximum, one of my first steps is to set the derivative equal to 0. So I'm going to call this a derivative problem. Part C, find all values for which the graph of G has a point of inflection. Okay, so points of inflection often have to do with a second derivative, or it's where our first derivative changes direction. So I'm going to call this a derivative problem. Part D, find the average rate of change. Well, hey, a rate of change is like a slope, and so I'm going to call this one a derivative problem. All right, let's keep moving along. Now we're on question number 5. Question number 5, use the line tangent to the graph. Well, whenever I'm writing the equation of a tangent line, I need to find the slope, which is the derivative. Now in this case, I don't have to find the derivative. It's been given to me in the problem. But still, I'll call this a derivative problem. And here, finding the second derivative, well, that's another derivative problem. And here in part C, where it says find the solution to the differential equation, I'm going to have to separate my variables, and then I'm going to have to integrate both sides after I get them separated by dividing both sides by w minus 300. So this involves integration. Our last question, number 6, is a really interesting one. It says show that f is continuous. Well, I know the definition of continuity has limits in it, and so that's the other big thing that we study in calculus. Derivatives, integrals, and limits. Those are our big three. On part B, express f prime as a piecewise defined function, so this is definitely a derivative problem. And then finally, finding the average value of something. Well, to find an average, you're going to add it up, and then you're going to be dividing by 1 minus a negative 1. So this one definitely involves integration. Okay, we've gone through this whole test. If you'd like to see details about how to work the problems, this is the 2011 released questions, and you can find these posted at AP Central. Thanks for listening today, and remember to enjoy calculus.